The last one, find the inverse of f of x equals the square root of x minus 6 where the domain of f is x such that x is greater than or equal to negative 6. State restrictions on its domain. So, again, our current function f of x equals the square root of x minus 6 is our function. They're giving us the domain. Obviously, that's the correct domain for this function, right? They gave it to us. If we just verify that fact, I want x minus 6. Oh, it should be positive 6 instead of negative 6. Tell you what.
That's weird.
I'm going to blame the book. Even though I'm the one who typed it. I'm the one who typed it. I put that minus sign.
It was.
Yeah. Anyway, it should be positive 6 there. If we weren't given the domain, we know for radicals x minus 6, the inside must be greater than or equal to 0, so therefore x must be greater than or equal to 6. That's how they're getting the domain there. As long as x is greater than or equal to 6, we're going to be taking the square root of either 0 or a positive number. All right, we know the square root of 0 is 0, right?
Yep.
The square root of anything positive is going to be positive, because we're taking the positive square root. So looking at the range of this thing, 0 is the smallest it could possibly be, then it gets bigger. So the range of this thing, if we just use our brain to establish that, f of x, the outcome should be greater than or equal to 0. Right, so again, establish domain and range of the function that's given to you. That's very important. And once you've established domain and range, again, we want to make the inverse function. So I take my original function, f of x equals x minus 6, write it in yx form. So y equals the square root of x minus 6. And that's the original function. I haven't done anything to it yet except that f of x became y. I swap the x and the y becomes x becomes y. Everything is where they were, so x was inside the radical, now y is inside the radical, y is all by itself, now x is all by itself. I want to get y equals, that requires me to get rid of the radical, so I'm going to square both sides. That's going to give me x squared on the left equals y minus 6 on the right. If I move the 6 to the other side, I get x squared plus 6 equals y. So once I get that to say y equals, that's my inverse function correctly created. I write it in good inverse function form, f negative 1x instead of y is equal to x squared plus 6. Now this is an example of one where the range is very important to find, because if I'm just looking at x squared plus 6 and not worrying about what f of x was, x squared plus 6, I can square anything, I can add 6 to anything, all real numbers would be the domain of this function to begin with. But our range up here says that f of x is only allowed to be greater than or equal to 0, which means that x on this function must only be greater than or equal to 0. There's a very important reason why that's true. If this is a function of x, all right, we want this also to be a function of x, all right, and they have to work with each other. So if I had this allowing x squared plus 6, if I was just to graph that, it would look like this. If I were to flip that over, make the inverse function, it's going to look like this. That means my original function wasn't really a function because the vertical line test fails. So what we're looking at here is that this is the part of the function that is, and this is its inverse here. So we're only getting that part of the graph because, again, inverse functions, that's what happens, is they get flipped or whatever. So whenever you're doing radical or square roots or radicals, either one, know that restriction occurs. Okay? If you end up with a radical, it's obvious the restriction is going to be whatever it is based on the rule. But when you get an answer that's a polynomial, you're going to get a restriction, even though there should be a restriction there when it comes to square roots. So again, each time you do domain, do a domain and range the original function to establish the domain of your answer. Don't look at the function itself to establish the domain of the answer. Sometimes they're the same, but sometimes they aren't. They're always the opposite. They're the same as the range, just with f of x's changed to x's. So it's the same structure, just change these to x's on your answer, so you have a good form of your answer.